Uh, Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. I'm just trying to sort out a link problem at the moment. But anyway, we've got welcome to tonight's session. The advantage of these sessions is that they are interactive, so you can send questions through on the Slack channel, and there's instructions how to join that, so learning to code, and also in YouTube chat. This is my view of YouTube chat. Maybe make it live chat so you can see everything, and I'll be looking at those questions during the session. Now we've got tonight's an online session using sqlite, and I'm hopefully using Google Collab. Next week we've got an in-person session at the Brisbane Business Hub, which is in Queen Street Mall. Really encourage people to attend to that. We've only got 8 attendees RSVP'd so far, and Arun will be taking that one on machine learning. He's just overseas at the moment, so he hasn't had time to put up much of the details of what he's going to be showing, but anyway, they're normally a great event, and it's a great place to ask questions and really overcoming problems that you might be having when you've got someone right there looking over your shoulder. All right, so tonight's one, sqlite. Now Leo said there's a problem with the Google Collab link, so let's give it a go. This one here. And that's opening fine for me. So if someone else is using Google Collab, if they could tell me that the link worked or it doesn't work, and I'll see what I can do. All right, now the first thing you do when you get it up, you probably want to copy it to your own drive so you can make changes and save them. Currently it says changes will not be saved. So let's hit copy to drive. And that'll open up a new tab, and it'll have the words copy of Meetup 173 at the beginning. Now I'm going to share this one as well, so that anything that I type, you can refresh your copy of this one and see what I've typed. But you'll have to have one that you're working on yourself, and the one here, which is the copy of what I've got, and you've also got the original one. So hopefully that'll give you everything you need. So let's copy that link, and I'll just post that to Slack and YouTube chat. So you can see I've sent it to YouTube chat. It may or may not turn up there. YouTube chat does a bit of censorship of URLs when people post them into the chat. Okay, so let's get started. Our learning objectives tonight are how to use sqlite 3, which is a relational database, and it's actually built in with Python. You don't need to install anything else to use it. I've got links here to this notebook, to the YouTube that you're currently watching, to the Meetup event, and also to our GitHub repository, where all of these notebooks that I use, I convert them to a Python script and save them in the repository, so you can use that as well as an alternative. All right, now relational databases are useful when you have different tables of data related to each other via some sort of key, and that key is called a foreign key in the table that it's from, and it's the primary key on the table that it's linked to. So we'll use the sessions we'll use the techniques learned from last session to collect some data from the internet, and then we'll put it into an SQLite database. And I'll give you a couple of links here, including the Brisbane City Council Open Data Project. He's got some there's some data there on telemetry sensors for rainfall and stream heights. I think I won't go into this in too much detail because we did it last week, so you can always look at last week's one to see more detail there. All right, now I thought I saw message. Okay, Leo says it's just a Firefox issue with Collab. Okay. Okay, so our first challenge was create a list of dictionaries of metadata and data from the telemetry sensors for rainfall and stream heights. So this is the resource ID for the metadata, and this is the resource ID for the measurement data. And if you have a look at Meetup 172, you'll see that this is the code that we need to do to run it. Now, to run these cells in Google Colab, you select the cell and you can click on this play button here, and the first one you click on, this will say connecting, and so it takes a little bit of time because Google sets up a computer engine backend for you, which is like a Ubuntu server running Python to run all the Python commands that you're sending through. Gives you a bit of RAM and a bit of disk space. We're just using standard Google Colab, the free one. We don't need any GPU acceleration for what we're doing tonight. So anyway, that's connected. And now we'll just run these cells. So we'll assign this resource IDs into these variables called resource ID meta, resource ID data. We'll send off, we'll use the requests library to get that URL with these parameters so that we get the particular data into these variables, and now we can have a look at it. Alright, so it's a really good idea to play along as we do these things. You press the play button on yours as well, and you should see these results. So we're looking at the raw data here, for example, and it's showing that we've converted it into a dictionary with keys and values. Now, this is a beginner's Python session, not really absolute beginners, but even so, feel free to ask any questions if there's anything you don't understand. Like if you don't understand what a dictionary is, just ask me, and I don't mind giving you a little brief introduction to these dictionaries. But if you know what they are, then that's great. So really, the only way to slow me down is asking questions. If you think I'm going too fast, ask questions. All right, so our data, we have each row of the data, it comes with an ID. It comes with a date that it was measured, the date stored in a string format. And then it's got each one of these keys is a sensor ID. And then each one of these values is what the reading is on that sensor. And sometimes it's a number and sometimes it's a dash. I'm not sure what the dash is, but I think that just means there was no reading at that time. All right. So let's have a look at the metadata, and we'll just look at the first 5 rows. So you can see this command here looks at the JSON from the response, looks up the dictionary key result, and in result there's a dictionary which has got another key called records, and in records it's a list of the raw data, and we're going to look at the first 5 rows of that, and we're just going to print them out. And so each one has an ID, has a sensor ID, which is one of these codes, E1809. It tells us where it is, so the location has a name and an ID. It's got the type, so rainfall, stream height, units of measure, whether it's millimeters or meters, and we've got latitude and longitude, so we know what the location is of this data, of this sensor. All right, so we've run that. All right, now we're going to get into the database side of things. So we've got data. This is just in memory data, just a list of dictionaries. We want to store it onto our drive, and we're going to store it in a database name. So that would be normally, if you're doing this on your computer, it will persist So when you finish the program, but you've saved the database, it will stay there. Google Colab's a little bit different. It will refresh this computer every time, this remote computer that we're connected to. So you will lose the database file. If you want to keep it, then you need to save it into your Google Drive, and then you can access it through Collab as well. But I won't be doing that. All right, so we're using the sqlite 3 library. That's one of the standard libraries with Python. We're going to connect to a database, and it's just a file, and I've called it Beginners Python and Machine Learning 173, because that's what our meetup number is. And I've put this extra parameter in here, detect types, parse the declared types, and we just need that if we want to use date and time values. So we don't need it for strings and numbers, but anyway, we'll do that. We'll put that there, and it will help us with working with dates and times, which we'll do later. All right, now SQLite is a bit different to your normal SQL database. A normal SQL database like PostgreSQL or MySQL or MariaDB, they need a server running on your computer. And SQLite 3 managed to achieve a lot of the functionality of those other databases without even running a server. So it's just a bunch of C routines that your Python program links to and calls them, and each one of them does the work of a SQL server, and it does it surprisingly well. So it's actually quite a good way of getting database functionality into your application, especially to start off with, because you know that anyone with Python on their computer is going to have the ability to create an SQLite 3 database. So the first thing we need to do is connect to the database, and we create a connection. I'm going to store this connection in a variable called con, C-O-N for connection. You can call it anything you like, obviously. So let's create it. And now that's created, if I look in the files that come with this notebook, you'll see it's now added very quickly. I thought it wasn't going to show straight away, but it's showing it straight away. bpaml173.db. So we've just created that file by doing that connect to it, because it worked out that it wasn't there, so it's created it for us. Okay, now we're going to create a table in there. So we create a table for every for storing data, and a table has got it's called a schema or a structure that basically says what the columns in the table are. So we're going to have tables called ID, ID sensor, ID location, text location, text type, and I've called these names slightly differently to what was in the original data, just so that you can see when I'm referring to the original data or when I'm referring to our SQL table. Now these ones are all storing text, but the latitude and longitude I'm storing as real numbers. Okay, so remember, we're just doing the metadata here, so it's just the sensors, it's not the measurements itself. So it's just where it is, what type it is, and what name it is. So these words, you can use things like varchar or float, but and SQLite's pretty forgiving on understanding different names and types that people use. There's this one here, BLOB, which stands for binary large object. So that's pretty much anything else other than text, integer, or real. And I'll give you a link here if you want to find out some more information about the different data types that you can create in your table. All right, so this is the command create table to create the table in SQL. And because it's in a Collab notebook, and we might be running cells backwards and forwards, because when you're running these, you tend to do them in all different order. I've put it in front of it, command drop table if it exists. So if our table called table sensor previously exists, then it drops it first and then creates an empty table. So that way I'm starting with an empty table. So otherwise, if I didn't have that in there, I tried to create it, I get an error if the table was already there. If I just said drop table sensor to start with, then if it didn't exist, then I'd get an error. So I'm just saying drop table if it exists, and it'll do that first. And you see I've separated my two SQL statements with semicolons, but I put them all in the one string, and I'll run them all together. So when you're running SQL in SQLite, there's three ways of doing it. You can use execute for one SQL statement when you want to get the results. Execute script when you have many SQL statements all separated by semicolons, but you're not getting any results from any of those. And execute many when you have one SQL statement, but you've got many items of parameter data that you want to feed into that SQL statement. So it'll run that one SQL statement many times, each time with a different parameter data. All right, so we use our connection object to call the method execute script, and we give it the SQL we want to run. And the result of that gets stored into a cursor. And a cursor is a way of looking at the results that you get. In this case, there aren't any results. But what's important is when you finish with that cursor is to close the cursor. When I've been running these scripts on not in Google Colab, just in a Python script, this doesn't seem to be such a problem. But I've noticed in Google Colab doing this that I was getting database locks quite a lot if I didn't make sure that every time I closed my cursor. So this is something you have to remember. Remember to close your cursor, especially if you're in Google Colab. Otherwise, you'll lock up your database and you'll have to just restart your whole notebook and create a database again from scratch. All right, so let's run this. And that's run. There's no output. And so we're going to check how to check if it's created. So it's what's hopefully happened is it's created a table called table sensor, and it's also created a table called sqlite master, which has probably got created when we originally created the connection, and this keeps track of all the tables that are there. So we're going to select all the names of everything that's been created in our database that's in SQLite master, and we're going to do this by running an SQL select query, and I'll go into select queries more later. Now, as you saw before, well, let's just run it and we'll see what happens. So it's returned two results, table sensor and SQLite auto index table sensor 1. And what the auto index is the index that is created on this ID sensor to keep track of our primary key on this table. So by saying primary key here, it's telling SQLite to create an index for us. So that's good. It's created that data for us. Now, before I showed you how to run it to execute some SQL, and I did it like this. And so I created a cursor by executing the SQL. Then I would have run the method fetch all on that cursor to get all the results from it, and stored it into a variable called rows. And then I would have to remember to close that cursor because I don't want to do anything more with it, and I don't want to lock up my database. And then I can do the commands to view what's in rows. And in fact, in Google Colab, it's just a Jupyter notebook, so I just say rows at the end, and it'll display whatever's in that variable. So this is the way we would have done it based on what we did before. But because cursor.close is such an important thing, I've done it this way using the with command, which Python with command is a way of starting a code block, and a code block's anything that's been indented like this, so that there's no way of exiting that code block without running the closing statement on the cursor. Now often if you're doing this with files, you use these with context libraries, you can just say with open and the file name as a file pointer, and it will close the file at the end. But the cursor hasn't been set up like that. You have to do a little bit more work, and you have to call this closing function around it, but it's not too bad. So, and to get that closing function, I imported it from context.lib up here. So now I imported that there, so now I can use closing all the way through here, and it'll automatically close my cursor whenever it exits this this code block, and I don't have to then call cursor.close, which you can see here. Alright, now the data that's come out of there is a list, as you can see, square brackets, and in each member of the list is a tuple. You can see these parentheses, just a one element tuple, because we only asked for name. So we asked for one field from each row, and it returned it to us in this tuple, and it's pretty easy to understand what it is in this case, because it's there's only one of them. But often the time we'll have many columns we'll be pulling the data out of, and they all just come through one long tuple. It'd be hard to know which is which column is which when we're just looking at these tuples. So the way we get around that is we SQLite provides a row data type that we can use as the row factory when it's manufacturing these rows, getting the data out of the database, and then we can convert that to a dictionary, and it will show the names. So let's run this using this row factory, and you can see if we print just the row straight, it just looks like this. But if we convert that to a dictionary, we can get this. Now there's a way of doing it where it just comes straight back as a dictionary, but this is actually more useful because a row is different to a dictionary in that the names here, the keys, are case insensitive, so which is how the database works as well. So you don't need to know whether it's upper or lower case to be able to retrieve data from each of these columns. Alright, challenge 2, prepare our metadata for insertion in the database. And what we have to do is rename the keys so that they don't include spaces. Now if you remember, this is what one row looked like out of our metadata database, and this dictionary, the keys have spaces in them, and that's a problem. So this is your challenge. How are we going to get rid of those spaces? So this is really, this is just a straight Python exercise really, but I mean that's what we're here to learn is how to use Python, and we're just doing that in the context of accessing our database. So let's say we've got a row R as the first row in our metadata. So let's have a look at it. There it is. There's the data with spaces in the keys. Okay, and we're going to create some parameters. So let's create a dictionary called P, and we'll go through each key and value in R, and R is a dictionary, so to get the keys and values we use r.items, otherwise it'll just give us the keys. And we want to change the key to be the old key but replace any spaces and we'll replace them with underscores. Okay, and then we can just say P of the new key equals the value. Okay, and let's have a look at what P looks like. So here's P. All the spaces have been converted to underscores. All right, now that was as a fair bit of code just to do that, and then we've got to do that for every row in our list metadata. So here's the solution provided. It does the same thing, only it uses dictionary comprehension. So all of this code up here, it's done in one line, and then it just appends each one of those lines into a new list called list meta rather than list meta raw. And let's run it and just have a look at the first two rows and just see that they came across okay. So yep, they both came across. They both be converted without spaces. So that was a fun little Python exercise. So I hope you had fun with that. So doing these exercises, like you always put the video on pause and do it, and then try to catch up later. Or and if you don't understand anything, of course, just ask. All right, now we need to insert this data into our database. We've created the table with field names that are slightly different to these names, and we want to insert this data into that table. Now there's a few different forms. I've given you a link here to the insert command for SQLite. You can say so it'll start off with insert into, then it gives the table name. And see how I've named the table TBL sensor? That's just really for me. You can call it anything you like. You don't have to put the TBL in front, but I find it a lot easier if I name all my tables with a TBL at the front. So that then when I'm looking at them in my code, I go, oh yeah, that's a table name that I'm looking at. Similarly, the field names, I go, oh yeah, that's an ID, that's a bunch of text. It just helps me to recognize what data type they are, but you don't need to do that. And a lot of people don't. So that's up to you, but I find it a lot clearer. All right, so we're inserting table sensor into values, and then we have to provide the parameters, and they get bound to where these question marks are. And the way this command works is that we have to provide the data in exactly the same order that the table got created, those columns got created in the table. Now I can never remember which order the columns got created in the table, so I don't like that form at all. So there's another form where I can say insert from a dictionary of keys and values. Now this means that I don't have to worry about getting my columns in my dictionary in the right order, but I do need to make sure that these names in my SQL are in the order that the table got created in. Once again, I don't remember what order the table got created in, so I don't find that one very useful. So this is the one I do. Insert into table sensor, open parentheses, and then I do the list of the columns in the table how I want to put them in, regardless of where they were created. And these are the values that I'm going to get out of my dictionary. And because I've named them, it doesn't matter what order they are in the dictionary, it means I can't use a tuple or a list, but that's okay with me. Okay, so we'll use this last one, insert into table sensor. All right, and I'll run that cell so that SQL saves that bit. All right, now we're going to execute that SQL, which it'll be the last one because it just overwrote the other two, with just the first row of data, list meta and just index 0 is the first row, and we're going to execute it. Now, remember that creates a cursor, and then when I leave this code block, it's going to get automatically closed for me. Now, what's different with this is that we're now actually creating data in the database, and so SQLite does what's called a transaction. And transactions are a way of, they were created for banks, for example, if they had a database and they wanted to put a record in the database to say some money had come out of someone's account, and then put another record in to say that money had gone into someone else's account. And that was what they called a transaction. It had two parts of the transaction, coming out of one account and going into the other account. Now they could update the first bit of data first and then the second bit of data. But what happened if the computer crashed halfway through between those two update commands? Then you'd have the money's come out of one account, but it hasn't gone into the other account, and so it'd be lost. So the concept of transactions was created where you did all the different changes to the database that you wanted, and then you committed the transaction, which meant all the different updates would happen or none of them would happen. And so you had to do what's called a commit command. And so SQLite does that. It allows us to do commits, and you do that by, on the connection, you call commit after you've finished executing all your SQL, which in this case is just one row. Now you need to commit after inserting values unless auto commit is turned on. So there is a thing in SQLite you can say, I just want to auto commit every line one by one as they go in, and if that's the sort of data you're working with, you can set that, but I'm just going to work with committing my transactions as I work through. All right, then I'm going to create another cursor and get the data out of that cursor and view it. Okay, so remember last time I used cursor fetch all. This time, this is another thing you can do with cursors, which is probably a bit easier. You just say for row in cursor and iterate over the cursor and you get each row that comes through. So let's have a look at what that does. So it's taken our ID1 and it's put the data into our database. And remember up here it looks like it's got names like this in our dictionary. And now it's, when we pull it out of the database, it's got the new names of our columns from the database. So that's saying sensor E1809 is located at 540801, which is at Forest Lake. It's a rainfall gauge measuring in millimeters. Its degrees latitude is minus 27.63. And notice how that is not a string. It's worked out that we wanted a number, even though we inserted it as a string in the original data. SQLite's converted it back to a number when we've pulled it back out. So that's a really nice feature. Okay, so challenge 3. Can you do the same thing for the second row of the table? So this should be pretty simple. So we'll just do a copy and paste. And we'll do that's the first row, so we'll do the second row and run that. And what I'm going to do here is also print what that second row is so that we can compare. All right, so it's run that, it's printed the 2 rows that are now in there. So we've just added this second row. So now there's 2 rows in there. And let's compare it with our dictionary. So we can see this is our original data, sensor ID E1531 has gone into ID sensor E1531. Location ID has gone to ID location. Location name's gone into text location. So we can see our data's gone in correctly. Okay. Now let's have a look at the solution. Solution 3 here. So the context manager we used for the closing our cursor can also be used for committing our transactions. And in fact, it's even easier. We don't have to use closing, because in this case it's not closing, it's actually calling con.commit, and we just say with con, and then we just nest our cursor context library here. It does this, and because we've actually got nothing to do in here with any code block, you need to put something in, but we haven't got anything we need to put in there, and comments don't work. So we have to put a Python command in there. So Python actually gives us this command called pass, which does nothing, and so we'll put that in there. And so that's indented. It needs to go in there so that it can tell, because Python works out by the indentation where the code blocks are. All right. So let's run this. Okay, now if I run this, it's going to put, if I run the solution, it's going to put this row in again. So let's do the next row. This meta 2. And there we go. So there's number 3, and that's gone in fine. All right, challenge 4, insert the remaining rows into the table. So once again, we can run this code. It's going to be slightly different because we've got to run execute many times. And let's do, I'll do from, well, let's say I'll do 3 to 10. Now, I can't do that in this with statement. So what I'll do is I'll just get the cursor. So we'll go con.cursor. So I'll get the cursor, and we'll call that as cursor, and then on the cursor I can run execute on cursor, not on the connection. If I did it on connection, it'd produce a new cursor every time. So I want to just use the one cursor, and I want to make sure that one cursor gets closed when I've finished. And I'm going to do that for rn list meta. So I've done 0, 1, 2, so I'll go 3, I'll do 7 records. And then we'll pull them out and have a look at them. So let's run that and see if it works. There we go. The next 7 records, 4, 5, 6, 7, 8, 9, 10. So that all worked. Now the solution here shows you that with when you're nesting with statements, you can actually write them on one line. So it's getting even simpler. So rather than writing with con with closing, we can just say with con closing on the one line. And then we can now use the execute many statement that we had before, and if we provide a list of data, it'll run through SQL, the same SQL for every row in our list of data. And we've done up to 10, so we'll go from 10 onwards. And we'll run that. And we can also reuse our open cursor. So as I did before, I got the cursor, I used as cursor here to get the cursor from here. If we wanted, I won't go into that. If and now we've got the cursor, it runs this command, but we're also using the same cursor to do the select, and the select is just going to do the count, not every individual record. And then when it leaves, then that cursor will be closed. So let's see. So we've got all 92 records have gone into table sensor. We're not listing them here, but we've done a count of them, and there's 92 of them. So any questions so far? You've been very quiet. But anyway, I hope that this is all working when you're running through it yourself. Okay, so challenge 5, try inserting the first row again. Okay, so let's just copy first row, which is this one. And I'll run that by pressing play. I'll just close this. We don't need this open anymore. So we've got an integrity error. And that's because we've created a primary key on ID sensor. And ID sensor says they have to be unique. Every sensor has to be unique. So if I've tried to insert data for the same sensor, it'll have the same sensor ID, I'll get this integrity error. So that's sqlite just helping to protect our data and making keeping integrity of the data really good. All right. Once again, commented out because it raised an exception. So this is the same thing. If I run that, it gives the exception. Now, I don't like leaving code in notebooks that will cause exceptions, because then if someone tries running them all from the top to the end, it'll stop when it gets to the one with the exception. So I just comment that out, and you could comment this one out as well. So let's see if I select all this code and I do Control/, then it'll just comment the whole lot out for me. All right, challenge 6, create a data structure for list data. So this is the measurement data. We've done all the sensors, so let's have a look at what the measurement data looks like. So we've got ID, measured, gives us a date, and then we've got a sensor ID and a measurement, sensor ID, measurement, sensor ID, measurement. Okay, so this is great for when you're working with pandas data frames. Pandas data frames stores all the data in columns. So storing a separate column for each sensor ID actually works. It's not something I'm really comfortable with, because I've come more from a database side of things rather than a data frame side of things, and databases store everything in rows. So this would be a bad data structure to use in a database, because every time you wanted to add a new sensor, you have to change the structure of your table rather than just adding in extra data. So it's best to create rows, an extra row for every sensor, and then we just have one measurement per row, and we identify when it was measured and what sensor measured it. So I think a good data structure would be something more along these lines. So we'll create our table. We'll have a measurement date, an ID for the sensor, and the actual measurement is a real number, so I've called it RL measurement, ID, sensor, and date measurement. So that'll be our measure table. And this ID sensor is going to be the foreign key that links to our metadata. So we say here that this is a foreign key that references this other table, and that just helps SQLite when it's creating its queries and selecting data, that it will, if it knows that there's a foreign key there, then it makes it a lot easier for it and quicker, so the performance will be better, and so that's good for everyone. Right, now we're going to use the execute script command to run this SQL. So I've got drop table if exists, table measure, semicolon, and create a table and semicolon to finish. I haven't specified a primary key at this stage. I've specified some constraints here. I've say, well, I'm not going to allow null values for the measurement date. I'm not going to allow null values for the sensor, but the measurement could be null for, I don't know why, but anyway, we'll just, in case it comes through as a null. Okay, now I've also put at the beginning a begin and a commit at the end. So this is the other way of doing your transactions. If you've got multiple SQL statements separated by semicolons, you start with a begin saying I'm opening a transaction and end with a commit. So just another way of doing it. So I just thought I'd show you that. So we'll create this SQL, and we'll create the table. So now we've got the table in there, and we could check in that SQLite master table to see if it's been created, but I'm pretty confident it has. And now we're going to put the data in there. Now I like to convert my measurement times to date times rather than submitting them as strings, so that then SQLite can do some of the data arithmetic that we need to do. You know, sometimes you need to say show me all the measurements that are a month old or something like that. So you need to do some data arithmetic, and if it's stored properly in dates, then that works. So we're going to use the standard library date time, and in that it's got a date time class, which we can call the class method string parse the time, and we're going to parse the time using this format. So year, month, day, a T, the letter T, then hour, minute, second, and there's colons and dashes in that string. So if you just remember what it looked like, that's what it looks like, the times that we get through. So time zone's another thing to be aware of, but at the moment we're in Brisbane. The data's come from a Brisbane place. I think we'll just we'll ignore time zones for now, but if you're doing a bigger program, anything that goes on a server really needs to have time zones stored with it as well, and normally you'd store it in UTC time, because it's that is unambiguous, and it's very important with times not to be ever have an ambiguous situation. All right, so the current dates and times are stored in measured column. We're going to store them in one called dt underscore measure. So let's do the whole lot and just print out the first row after it's been done. So there's the first row, there's measured was the original, and now we'll have a look right at the end. We'll see that it created a date time with a year, month, day, hour, minute. So let's see, year, month, day, hour, minute. Yep, it's got the right. So it did the conversion properly. Okay, now we're going to insert this data into our measurement table. We've only got 3 columns to insert, but we've got lots of data here. So what we're going to have to do is we're going to have to loop across our data. So we'll start off with so we're doing one row this time. So we'll take the first row, which is index 0, and store it in our variable called raw, because that's our raw data. So we just made that name up. With con, so we get an auto commit, and closing, so we get an auto close of the cursor. We want to loop through all of the items, all the keys and values in raw. So this is what raw is going to look like. Now, if the key is ID or measured, we're not really interested in it. We're not saving those 2 columns. These IDs, we're not saving them at all because they're really meaningless. If like 10 minutes later, if I pulled up the same data, the same record here would have a different ID. So it's not anything I can use. But the measured is something I can use, because that will be the same for the same set of data, regardless of when I actually extract it. But I'm going to use my DT measure rather than this one measured. All right, so if K is not in ID or measured, and V doesn't equal dash. Oh, okay, so the dashes, I want to avoid these dashes because I think they're just when no readings happen, so I don't need to create a record in that case. All right, but every other time, every other one of these is going to be a record. That's going to be a record, that's going to be a record, that's going to be a record. Okay, so, and each record, so I'll create data, it's going to be a record. It's going to have a DT measure, and I'm going to get that from my row DT measure. And it's going to have a sensor ID, and I'm going to get that from my K, which is not one of these, and my measurement, which I'm going to get from my V, because I know V is not a dash. And then I'm going to execute the SQL. I'm then going to look at the first 5 rows that I've created, and then it's going to exit out of the code block and close my cursor off and commit my transaction. And there we go. That was all happened very quickly. I've created the measure, so the time of the measure was at 20 to 6 today, and there's each of the sensors, 1809, 1531, 1515, so you can see it's just working its way through here, 1809, 1531, 1515, and it's putting in these measurements, 0, 2.46, 0, so 0, 2.46, 0, 0, 0. So it's got the right data there. Okay, challenge 7 is add the remaining data. I think we'll just look at the solution for this one. So we're going to create a list of data. We're going to do every row except the first one because we've already done the first run, and this is in our list data of raw. We're going to store each one of those into value raw, and then just like we did up here, we're going to loop through the keys and values in items. We're not going to do anything if the key is ID or measured. If it's not that, it's going to loop back to here and go to the next one. Measured, no, loop back to here. Then it's going to have a sensor ID. So then it's okay. But first of all, we'll check, is the value dash? It's not. If it's not, then we'll create our record. And this time, rather than running the SQL, we'll put it into a list. And that'll make it a lot faster when we have to insert the data. So we've created our list of data to append. It's just all of these rows. Then we can use our code block for automatically committing when we leave the code block, and automatically closing the cursor, and using the execute many. And we'll look at the cursor to tell us how many rows got inserted, and that's just actually in a property of cursor row count, and I've just used an F string here to look at the value of that. So let's see how that went. So that's just inserted 6,287. So you can see it's pretty fast, and this execute many is a really fast way of adding this data into our database. All right, now how do we get the data out? And that's with the select queries. So here's an example of a select query. So when you do select, it's saying I want to get data out of the database. What comes after the select is what columns we want, and you can there's a shortcut. You do an asterisk if you want every column. You say where you want the data to, which table you want the data to come from. So from table sensor, and you say what conditions you want. So we can say where the latitude is greater than minus 27.4, and the sensor starts with E18 and then something else. So let's have a look at some of this. I'm just going to run through these examples because this is really SQL. It's not really Python, but you can see the sort of the power of the things that we can do. So if we look at the latitudes, they're all above minus 27.4, and if we look at the sensors, they're all E18, and that's all it returned is just the five sensors. Okay, now we can query relational data. So if you look at this, I'm saying from table measure joined on table sensor. So we've got two tables and we're joining them, and I've put these little aliases in there, M for measure, S for sensor, and I'm saying my sensor ID sensor has to be the same as my sensor, and then that way I can look at data from both tables joined into one particular table. and I can even do conditions based on the latitude from the sensor, from the measurement, so any measurement that's not 0. I can sort them, and I can limit the number that come back to 30. So let's run this and see how it comes. So you can see I've used some fancy print strings here to show the data coming out in a table. It's all rainfall. Oh, it's a couple of stream heights here, so that's good. And there'll be 30 of them that satisfy those criteria. E8143. Okay, so and here we're just going to have a quick look at some of the data in our raw data, just to see if it correlates. So yeah, 1.02, 0.97, 0.92, that's the same data here. So you can see that that's just a double check to make sure that our data from the database is the same as our data in the that we recovered from the query. Okay. Data constraints, you saw before how to the primary key add a constraint on uniqueness. We can do that on any key actually. So for example, we can make sure that the combination of date and sensor ID in measure is unique, and we'll call this index sensor time. So we'll create a new index on that. So that created pretty easily. You know all this format pretty well. And now if we try to enter some more data into there, and so I'll better uncomment that, you'll see, so we're just trying to enter row 1 again. We'll see we'll get an error, and that's because we've already got that data in our database. So some of the things you can use databases for, they're really good at aggregate functions. So for example, we can count all the records or sum our measurements based on a particular criteria. So if I run that, that's frequency. This is created a new column frequency, which is this count star as frequency. It's created a new column total, which is the sum of the measurements, sum as total, and it also shows my sensor ID and the units. So 294 meters, 383 meters, they're all meters, and millimeters down here, 59 millimeters for those ones. So that's, you know, quite a, and this is all for ones that had a frequency greater than 3. So you can see frequency 75, 71. So use where for a normal criterion, but if you want a criterion on one of the ones that's been aggregated, you use having. So let's just check that that's working. We'll do less than 2 and run it again. And yep, they all come frequency 1, so that's that worked. All right, if you want to update some existing data, use the update command. So once again, update, what the name of the table is, set then what the name of the field is, what you want to change the data to, and I'm changing the type from rainfall with a capital R to rainfall with a lowercase r. And let's run that, and so it says 48 records got changed, and then I said, all right, so show me all the ones that now have a capital R and there's nothing got shown. So if I change that second one to lowercase r and run, it just says now no records got changed because they already were lowercase, but this is all the ones now that are using lowercase r. Deleting data, so now you could delete all that data that's in the rainfall and just keep your stream heights. And that was looking at that. So if I run this, so we deleted 48. I remember there were 92 to start with, and the number that are left is just 44. And that's the end of our session, so we can close our connection. Con.close. And that's it. So I hope you enjoyed that. Try to come along next week to our in-person session at in Queen Street Mall. If you like the video, click on like. You can even subscribe. I've got a couple of hundred subscribers. This week we've actually got 1,500 members, as we've reached a new milestone for the number of people in our meetup group. So it's great to see all the people joining up, and really enjoyed having your company. Arun's taking the next session, and probably the next online sessions will be machine learning as well. And then the first week of March, we'll try to do an absolute beginner. So if you haven't done any Python at all, we'll show you how to get started in Python. And and once you get started, then that can actually be the hardest thing, is how do you get started. All right. Thank you, Meng Chia Chang, and anyone else who's been watching. I imagine Leo is watching. I hope he's used Chrome rather than Firefox. And we'll see you next time.